To start off, our planet that we chose was WASP 12b, which has a mass of 2.67 times 10 to the 27th kilograms. It has an orbital period in seconds of 94,299 seconds, and it has a radius of 1.214 times 10 to the 8th meters. Our star that we chose, which WASP 12b revolves around, is WASP 12, which has a mass of 2.69 times 10 to the 30th kilograms, and it has a radius of 1.113 times 10 to the 9th meters.
An additional interesting fact would be that the planet WASP 12b is gradually being eaten away by its star due to its superheated temperatures.
In order to calculate the gravitational acceleration, we use the equation little g equals big G times the mass over the radius squared. And the answer that we received is 12.1 meters per second squared as the gravitational constant, which is 2.28 meters squared larger than the Earth's gravitational acceleration. In order to calculate the velocity of a satellite that is revolving around our planet 400 kilometers away, we use the equation v equals the square root of the g, or the gravitational constant, times the mass of the planet divided by the radius of the planet plus the distance from the satellite. And the velocity of the satellite around the planet 400 kilometers away is 3.82 times 10 to the 4th meters per second. In order to determine the number of revolutions in one Earth day that the satellite makes, we first need to determine the time it takes for it, which can be calculated via the circumference divided by the velocity, which is basically 20013.9 seconds, which we then convert it into days via dimensional analysis, and we received 0.231 days, and we needed to find the frequency, which is basically the number of revolutions, and we got 4.32 revolutions per Earth day. So in order to calculate the distance between the planet and the star, we use the equation t squared equals 4 pi squared r cubed over the constant of g times m. And then we isolated the variable 4r, in which the equation would end up being r equals the cube root of t squared times the constant g times the mass of the actual star divided by 4 pi squared, and that would be all underneath the cube root. And our answer was 3.43 times 10 to the 9th meters, which is the distance between the planet and the star. So in order to find the orbital velocity of the planet around the sun, we use the orbital velocity equation, which is the v orbit equals the square root of the g constant times the mass of the star divided by the distance between the planet and the sun. And we got 2.29 times 10 to the 5th meters per second, which is how fast the planet is orbiting around its star WASP 12.